In this video, we are going to talk about how to use a calculator to get some of the trig function values that we've been talking about in class. For those of you that do not have a traditional handheld calculator, you're going to use the free website Desmos for your calculations. From the main website, you can click on the Math Tools option, and there is a scientific calculator which will be similar to a calculator that you would use for this class typically. There's a fraction button here, which is nice and useful when we're talking about any kind of problems that involve fractions. Most calculators have only 3 of the 6 trig functions represented: the sine, the cosine, and the tangent. So if we wanted to figure out, let's say, the sine of 45 degrees, we could enter it, and we can see the decimal version here. Now, in class, we've been talking about the exact answers. The exact value for the sine of 45 degrees is the square root of 2 divided by 2. Entering that fraction, I can see that the decimal versions are the same. When I have the decimal version, that is called the approximate answer. It's approximated because when you have a square root that cannot be simplified, such as the square root of 2, the decimal version has an infinite number of places after the decimal point. It's going to go on endlessly. In this case, where we're looking at the calculator, it ends simply because the calculator has run out of digits in its display window. But we do know that this is an irrational number and will continue endlessly. Suppose we were looking at the cosine of 30 degrees. The cosine of 30 degrees is the square root of 3 over 2. I can see, looking at this in the calculator here, that those two values are the same. Most of the time within our class, we'll be wanting to reference the exact value, and so we would list the square root of 3 over 2 as our answer. Suppose we wanted to look at the tangent of 60 degrees. We get this number 1.732 and so on. We don't really know exactly what that is, and so this is one that you would want to be able to calculate by hand, thinking about what the sine and the cosine of those values are. It turns out that the tangent of 60 degrees is the square root of 3. And I can see that those two values match up. Now, what do I do if I want to find the other 3, the secant, cosecant, or cotangent? Suppose I want the cosecant of 30 degrees. Well, cosecant is 1 over the sine, right? Let me open up a whiteboard here. The cosecant of 30 degrees is 1 over the sine of 30 degrees. They're reciprocals. So that's the way that I'll type this into the calculator. I'm going to use the fraction button. I'll type in 1 over the sine of 30 degrees. And it tells me that the answer is 2. That's because the sine of 30 degrees is 1/2. So it makes sense that the cosecant is going to be that reciprocal, or 2. Similarly, if I want to find the cotangent of 60 degrees, that will be 1 over the tangent of 60 degrees. So I will type in 1 over tangent 60 degrees. And I'm getting this value here, 0.577, and so on. looking back to what we had up above, the tangent of 60 degrees was square root of 3. So if I typed into the calculator the reciprocal of that, 1 over the square root of 3, I get the same decimal answer. Now remember, we typically won't write our answers with a square root in the denominator like that. When we have something that has a square root, what we would do is we would say, well, we need to clear that square root by multiplying both the top and the bottom by the square root of 3. And that would end up being square root of 3 over 3. So again, the correct way we would write this answer for the cotangent of 60 degrees would be the square root of 3 divided by 3. I can see that all three of these answers are equivalent. This last one is the exact answer, the way that we would want it written. And this is the format that we use to get these values from the calculator. One thing to point out is that right here in the middle, this lets us toggle between radians and degrees. We will be talking about radians after our first exam, so you don't need to worry about that at the moment. Now let's switch from the scientific calculator to the graphing calculator. One of the interesting things about the graphing calculator is that it actually will allow us to type in, it's got the other functions. So cotangent is sitting here. So I could do cotangent of, I need to make sure I'm in degrees. In the graphing calculator, up in the right-hand corner, there's this little wrench. And down at the bottom here, it lets you switch between radians and degrees. I need to make sure that I'm in degrees before I calculate here. Let's do the cotangent of 60 degrees, which is what we were just looking at. Again, I get the exact same decimal answer, but I, as your instructor, I'm wanting you to give me the exact answer, that square root of 3 over 3. But some of the problems that we'll be looking at in class are ones that are not on the unit circle. So I might want to find, for example, the secant of 52.4 degrees. And this is nice because it's going to give me that decimal answer. We'll have it rounded to a certain number of places after the decimal point. And again, these are ones that are not specifically on the unit circle. Let's suppose that I wanted to find the cosine of 168 degrees. I can enter it just like this, and it gives me the decimal value. What to do is introduce a new form of notation, which is called the inverse function. Inverse trig function notation. If I want to think about, let's say, the cosine of 30 degrees, the cosine of 30 degrees is the square root of 3 over 2. But if I want to go in the reverse and I want to say, all right, the cosine of some angle, I don't know what it is equal to the square root of 3 over 2, I could say that this should be 30 degrees based on looking at what I had above here, right? But if I think about all of the different options on the unit circle, all the different triangles that are created, there's actually multiple locations where the cosine, remember the x-coordinate, is equal to square root of 3 over 2. There's actually 2 here. So 30 degrees is one option, but 330 degrees is also another option. That has to do with the fact that the x-coordinate is what we're talking about. So if we draw a triangle here, we draw a triangle here. Here's our two triangles. The x-coordinate is the same for both of them. It's this distance, right? One is in the first quadrant, one is in the fourth quadrant. So we actually have two different answers here. It could also be 330 degrees. Anytime that we go in the reverse, there are two different answers. You've seen this idea before when you've thought about square roots. If I take the number 5 and I square it, that'll give me 25. But if I go in reverse and I take the square root of 25, there's actually two possibilities I could get. I could have either 5 or I could have -5. I don't know which of those two numbers was squared to get to the 25, so I have to put them both as a potential answer. Same thing here. I don't know which of the two angles was considered initially, so I have to put them both as a possible answer. The way that this will normally be written in a math problem that you'll come across is with an inverse notation. So it would look like cosine with a little -1 above, and then it'll give you the value. So what this is asking is what angle has a cosine value of square root 3 over 2. Again, we could write it this way: cosine of what angle equals square root 3 over 2. And in the calculator, and we'll see this on Desmos in a minute, we can enter it just like this. Let's switch to Desmos. I'm going to go to the functions, and I see that cosine inverse is one of the options. And I will put a fraction. Let's do square root 3 divided by, oh, I don't want it to go that way. I need to get out of the square root first, then hit divided by 2. And it gives me 30 degrees. What I want you to see is that the calculator will only give you one of the options even though there are two. And so you've got to think through, reason through, okay, the calculator gave me one of the answers, and that answer is right here in the first quadrant. Where is the other place where the cosine is also a positive number? It's also in the fourth quadrant. And this angle here would be 30 degrees. So that means that if we went all the way around like this, we would be at 330 degrees. That's where we get the second answer. Let's look at another example like that. Suppose we want to think about the tangent inverse of the square root of 3. What this is asking us is what angle, or angles in this case, have a tangent of square root 3. That's what this little -1 as an exponent means up above. Writing it out more formally, we're saying the tangent of some angle, we don't know what the angle is equal to the square root of 3. In the calculator, we're going to enter this. This is what we type into the calculator. So we have tangent inverse square root of 3. It tells us that 60 degrees is one of the angles. So our angle is 60 degrees. We know that there's another answer somewhere. So we have a triangle here at 60 degrees. We need to figure out where is the other answer. The value that we were given for the tangent was a positive number. And tangent is positive, in the first quadrant, and tangent is also positive in the fourth quadrant. So I draw a triangle here that's going to mimic, let me move this over, hang on. I'm going to draw a triangle that's going to mimic that one in the first quadrant. I know I'm going to have a triangle that looks like this. The right angle is going to be here, and the 60-degree angle is right next to the origin, right? And so I'm trying to say, okay, my angle is going to start at the positive x-axis and go all the way around to here. So it looks like we're traveling 180 degrees plus another 60 degrees. I think that the answer is going to be 240 degrees. Let's double check on our calculator. What is the tangent of 240 degrees? We're getting 1.7. Let's see if that's the same as the square root of 3. And it is. So we've just verified that. So our second answer is going to be 240 degrees. Okay, let's do one more. Suppose that we want to find sine inverse of square root 2 over 2. This is asking us what angles have a sine of square root 2 over 2. The sine of what angle equals root 2 over 2? In the calculator, I'll enter sine inverse. Again, I'm going to plug in a sine value and it's going to give me back an angle. Square root of 2 over 2. Oops. And it tells me that it's 45 degrees. So know that one of my angles is 45 degrees. I need to determine where the other angle is. So I've got one triangle drawn here, 45 degrees. And I want to think about where is the other quadrant where the sine is positive. Sine is positive here, and sine is also positive here. So I'm going to draw a mirror image of that triangle over here. I know that the right angle has to sit on the x-axis. The reference angle is right next to the origin, and the angle that I want goes from the positive x-axis here to this side. So it looks like it's going to be 90 plus 45. I think my second angle was going to be 135 degrees. Let's double check. What is the sine of 135 degrees? We get this 0.7, and we think that that should be the square root of 2 divided by 2, and it is, same number. All right, one more thing that I want to show you, and it just comes up in a couple of applications. So it's called degrees, minutes, seconds. In some applications, we want to be more precise about the angle that we're measuring. particularly when we think about something like a mission that's going into outer space, where a satellite or a space shuttle has to go at a particular trajectory toward Mars. We've got some missions to Mars that are taking place real recently. The subtlety of the angle has to be very precise, and so an entire degree might be too big of a measurement. And so sometimes what we'll do, we had a problem I just did a minute ago, we'll look at what are called decimal degrees, where it's just more digits after the decimal point, right? The way that this traditionally is listed, though, is in degrees, minutes, seconds. So I might have something that said 21 degrees, 42 minutes, and 12 seconds. The first tick mark relates to minutes, and then the second tick mark, 2 double tick marks, relates to seconds. Similar to a clock, we have that 60 minutes equals 1 degree, and 60 seconds equals 1 minute. To switch back and forth between degrees, minutes, seconds, and decimal degrees, I'm going to use the number 60 as a bridge. So suppose that I had this last example over here, 45.5 degrees. Well, half of a degree, 0.5 would be the same as half. Half of a degree is going to be 30 minutes. 60 minutes would be 1 degree, right? So half of a whole degree is going to be 30 minutes. So I could rewrite this as 45 degrees and then 30 minutes. Suppose I have 12 degrees, 15 minutes, and I want to change it to decimal degrees. Most of the time we go in this direction because we're going to enter it into a calculator and we want the decimal version. So the calculation I'll do is 12. The number of total degrees stays the same. And then I'm going to take 15 divided by 60 because there's 15 out of 60 minutes total. So plugging this into the calculator, we get 12.25. Let's do another one. Let's take 13 degrees, 12 minutes. This would be 213. I keep the number of degrees the same, and then I take 12 and divide it by 60. That gives me 213.2. Don't forget your degree symbol. I did up here. If you happen to have, which we don't very often in this class, degrees, minutes, and seconds, we'll take the full number of degrees, and as it is, we'll add the 15 over 60, and then we'll add 30 over 3,600. Where am I getting 3,600? Well, if I go here, this is multiplied by 60, And then if I go here, it's multiplied by another 60. If I take 60 times 60, I'll get 3600. So the decimal degrees for this are going to be, again, we're just plugging this into the calculator. $25.28. Sorry, there's a 5 there. 258, and then the 3 is repeating. Normally, we'll have a certain number of places that we're going to round the decimal to. Let's just round it to 6 places in this case. All right, if you have questions, you can send me an email. Thanks for watching, and I will see you in class.